Hi everyone, my name is Sivasan Selvan and my matrix number is CD190170. Today I would like to present about introduction. Okay, many materials and components are subjected to torsional forces during the operations. Products such as shafts, switches, furnace, and automatic steering columns are just a few. Manufacturers are able to reply the circumference of the real-world operation, test the quality of the goods, and verify the price of commodity, design and ensure the proper production. The properties are modulus of elastic in yield shear strength, ultimate the shear strength, and modulus of rupture in shear of ductility. Okay, the next is objective. The objective of the torsion test is to determine the action of the material or test the sample when twisted or under the torsional forces as a result of applied moments that trigger shear stress on the axis. Measurable values include the modulus shear elasticity, shear strength, torsional fatigue life, ductility, ultimate shear strength, and modulus of shear rupture. These values are similar but not the same, calculated by the tensile tests are important in manufacturing because they can be simulate the service conditions to ensure that it has been correct manufacturance. Thank you.
Hi, my name is Tainan Sanam Krishnamurthy. My matrix number is AD 190069. So today I'll be talking about experimental theory. There are several tests that have been carried out to notice the effects of shearing force and resulting stresses. Besides all the tests, there is a specific test that has been carried out to notice the effects of the forces and stress on the circular bar or rod. That test is called torsion test. This test would show us the most notable effect of the forces and stress on the bar or rod. This test actually generates a state of pure shear stress in the torsional loaded rod, and it is also widely and majorly used on metal materials to attain its ultimate shear stress, the yield shear stress and modulus of rigidity of shear modulus. Torsion testing is a type of mechanical testing that evaluates the properties of materials under stress from angular displacement. It can be split into two separate categories for testing raw materials like metal wires or plastic tubing in order to determine properties such as shear strength and modulus. Second would be for functional testing to test finished products subject to torsion such as screws and pharmaceutical bottles. So, it is necessary when engineer wish to change or update the materials used in this product so that engineers can get a high quality and also safe product for the users. And then during torsion, right cross section of the original configuration of the element rotate with respect of the opposite face, and points B and D move to B prime and D prime respectively. The length of the side does not change, and the angles on the other hand will not be 90 degrees. Therefore, the element is going through a process called pure shear, and the magnitude of shear strain gamma will be equivalent to the decrement in the angle BAC. And then the angle would be as the formula tangent y is equals to B prime over AB. Note that tangent y is approximately equivalent to to gamma because the angle is small due to pure torsion. The distance VB is the length of small arc of radius subtended by the radius r subtended by the angle phi, which is the angle of rotation of one cross section with respect to the other. The AB distance is equal to the length of element dx. Substitute this expression and you'll get your formula right there, the gamma. And during pure torsion, rate of change d phi over dx of the angle of twist are constant along the length of the bar. This constant equals to the angle of twist per unit length. Thus, theta equals to phi over L, where L is the length of the shaft. So we have the formula right there. And then this figure 7.3, the shear force acting on an element of area dA, shown in the shaded figure, as you can see in the figure, and the moment of the fall equals to, you can see g theta p square dA. Total torque is the total over the entire cross-sectional area of this moment. You can see the top right there, the formula. And then right here we have all formulas that is used in this test, where J is actually a polar moment of initial circular cross-section. Therefore, theta is equals to T over Gj. And then we have phi equals to theta L, and also we have the phi, which can also be as G if it's in G. This is the result we wanted. The experiment you're about to perform will yield data on the torque T and the angle phi from which we can calculate G, the shear modulus given the dimension of the shaft. Important to note that for a solid shaft or uniform radius, J is equal to pi r to the power 4 over 2, and you have the other from pi d to the power 4 over 32. And that is all for the experimental theory. We have all I have stated all the formulas, and now we are going to talk about the procedure. The procedure is actually very simple. The specimen's length and diameter are recorded and measured at 3 different parts of the specimen. The average length and diameter of the specimen has to be calculated to ensure an accurate reading, because when we take the average length and diameter, we actually get an average reading. On top of that, the length of the pulley has to be measured. The specimen is mounted in the testing machine, and test is carried out with the assistance of the lab instructor, of course. Before starting, we have to make sure the pulley is in horizontal position. The angle indicator is placed or attached and readings have to be at 0. The load will be added from 0 Newton to 200 Newton and will be removed from 200 Newton and 0 Newton for both the specimen. Thus, the reading has to be measured. The reading that has to be measured is the angle of twist for both specimens. After the reading has been taken, table 7.2 and 7.3 has to be filled for further calculations. So I have explained the experimental theory and procedure. That is all.
Hello
Thank
guys,
you.
I'm Sinjia King. Matrix number 190230. Today I'm going to present about the result and the calculation path of our experiment, the torsion test. First, we require to find the diameter and the gauge length of the specimen. We take the value couple times and get the average value to avoid the parallax error. And we also find the length of pulley. Second, we find the angle of twist during addition of load and during removal of load. We use the load from 0 to 200 Newton, and it shows that the angle of twist will increase while the load increases, and it also decreases while the load decreases. This is the calculation part. In this part, we require to find the torsion constant and shear modulus for brass and mild steel specimen, and also determine the shear stress and strain for both specimens. So for torsion constant, which we symbolize it as T, is equal to force times radius. Shear modulus, which we symbolize as G, is equal to the torsion constant times length of the specimen, divided by the product of the dimension of shaft times the angle of twist. So for the dimension of shaft is equal to the pi times diameter power 4 divided by 32. For brass, the dimension of shaft is 1.56 times 10 power negative 10 meter power 4. And for mild steel is 1.50 times 10 power negative 10 meter power 4. Below it is the torsion constant result for brass and mild steel. It shows that the torsion constant of the brass and mild steel is increasing while the load is increasing. And below it is the shear modulus result for brass and mild steel. Before we include the angle into the calculation, we convert the degree unit to radian for angle of twist using formula 2 pi divided by 360 radian. So from the shear modulus result for brass and mild steel, we observe that during addition of load, the value of shear modulus is the highest when the load is 50 Newton, and it gradually decreases while the load increases. But for the removal of load, the value of the shear modulus decreases while the load is decreased. This is the result of shear strength and shear stress for brass and mild steel. For shear strength, which we symbolize it as gamma, is equal to radius times the angle of twist divided by the length of shaft. Shear stress is equal to the shear modulus times the shear strength. From the shear strength for brass and mild steel, we observe that during additional of load, the value of shear strength is increased while the load is increased, and decreased while the load is decreased. But the value of shear strength will not back to 0 even when the removal of load is totally complete. Below it is the table of shear stress. So from the table, we observe that the value of shear stress during additional of load and removal of load is the same if the load added is the same. So from the table, we also observe that the shear strength is increased while the load is increased, and it decreased while the load is decreased.
Okay, today I would like to explain about this question. First of all, first question is, if the cross-section of shaft is not in cylinder, explain how to perform the torsion analysis. Okay, if the shaft is not in cylinder, the formula in deforming shear stress, torque, and the angle of twist will differ. Hence, a shaft which is not in the circular shape, it will differ in different formula. Okay, second question, briefly explain some of the important factors in designing a high-quality shaft. Okay, there is 4 factors, which is ductility, malleability, toughness, and hardness. First, ductility. Both shaft twisted didn't drop back to 0 because occur in sliding of material arrangement. And second, malleability. Both shaft twisted are reducing upon removal of load. It is because the specimen is elastic, deformed, and recovered to its original shape. Third, toughness. To withstand the high loads, which also shown that both shafts have different hardness. And last is hardness. Brass shaft twisted more than mild steel because mild steel are more harder than brass steel. Okay, first of all, torsion test is a test to testing the brittle materials such as mild steel. Okay, torsion test is to analyze the deformation of circular shaft when subjected to torque, and the ability of material should be measured to withstand the twisting load. Then, the torque is the product of tangential force multiplied by the radius distance from twisting axis. The shear modulus is based on the position, load applied.
Hello everyone, my name is Aiman Daniel bin Muhammad. My metric number is CD190022. Today I would like to present about recommendation. My first point is test with other material. We can test with another material to study about the strength and brittle for another material such as alloy or cast iron. Second is analyze other shape of material. To analyze the deformation of material in other than cylinder shape such as square or tapered, because another angle of twist and diameter will be different cross section and get different result. My last point is more accurate machine. test with more accurate machine to get an accurate calculation for a specified material. That's all for me. Thank you.